Hi everyone. Um, this paper is titled as What Makes Good in Context Examples for GPT-3. So the motivation behind this paper is it's difficult to find the prompt for GPT-3. So they came up with a new um, method called Kate. So what they do here is they use KNN to filter out the in-context examples from the training set. So this is how the method looks like. So let's see here. So this is the model, GPT-3 model, and this is the input to the model where we have question answer. So these are the in context examples and the question itself, and the answer the model is gonna predict. So the choice of these examples is what they it's where they use KNN. So suppose this is same as this one. So they use this to filter out. So what they want to do is they take this test prompt, put it in an encoder and get the encoding of it. And similarly, they also get the encoding for each of the source from the training data. And they also try to measure, they basically want to find the k nearest neighbors of this test prompt and then use that as their in context examples. So they use two types of sentence encoders. One is Roberta L, which is not fine-tuned on anything, so it's a pre-trained model. And second is it is specifically trained on specific data sets. Those are the two versions. And so I'll give you a little bit of some experiment setup. So this is the key idea of this paper, and they will show that there is some improvement in the results. This is the same algorithm where they have this is the encoded test, and so you can have a look at it if you want. And they used kind of two types of encoders. So this is some details about the data sets they used. So they used three kind of data sets: sentiment analysis, table to text generation, and question answering. So let me go back to the results. Okay, so for each, so this is for sentiment analysis. They did it on SST2 dataset. So in the random version, what they used is they pick the in context examples randomly, and here the k is 3, so 3 examples. In KNN Roberta, what they do is they pick the nearest neighbor from the training set, and they just use it as it is. I mean, this is the motivation behind using this KNN Roberta is to investigate whether the retrieval module is complementary to GPT's learning ability, or it's basically because of the nearest neighbor baseline. So that's there. And then Kate Roberta is the Kate which is not fine-tuned. Then Kate NLI is Roberta fine-tuned on NLI. This is fine-tuned on NLI, STS and STS-B, and this is on STS-2. So obviously by even also intuition we know that it should perform better, which is fine-tuned on that dataset. But overall it doesn't give like much improvement, but there's still something for sentiment analysis. For the next one, this is for TTO datasets. It's like from Wikipedia table to text generation. So what they have here is the same things, and they have these two metric to compare, and I mean, this is the example of the data sets, and here also they find that, I mean, here the improvement is better, like it's like around 11% from the random, so here it is better. And then they also tried, so this is for question answering, the result, this is for question answering data sets. So they also tried some different other methods, and so here what they found was, even I think it's not a lot of improvement, but still there is something like kind of 5%, like, yeah, if you compare it with the random, it's still like 9%. From here it is also like kind of, but here the performance for the fine-tuned versions were better. Earlier they were for only for pre-trained models. And then they also talk about whether number of in-context examples matters, and they tried with the different numbers, and what they found was Gate consistently outperforms the random method even when the number of in-context examples is as few as 5. So more, if you have like more in context, it's gonna benefit the model. And the size of the training, okay, so this is like a summary of things, like if you increase the number of in context, the performance gonna improve, and also if you increase the size of the training set from where it is filtering out, then also the result is gonna improve. So they talk about a little bit of order of in-context examples, but what they found was that the example order does not have a significant impact. But in the next paper, we will find that the order matters a lot. So let's see. So this is all for this paper. So if we have any use case for GPT-3, we can use this method maybe. Thank you.